Alright, so I'm going to start talking about roots and zeros of functions. And you can use these two words interchangeably. They pretty much mean the same thing. So if someone says, hey, find the roots of this function, they mean the same thing as, hey, find the zeros of this function. It's also going to be a long string of videos because there's a lot to go into, but I can get through it. So suppose we have a function f of x, and I just drew some generic f right here. And a zero is basically whenever the function crosses the x-axis. That's the visual way of looking at it. But you'll see later on that there's also complex zeros, and those don't really cross the x-axis. But basically, if a is a zero of this function, since f of a is 0. And it can also be where I can also say b is a 0, since f of b is 0. And also, b can be real or complex. So it could be like something like 4, -2, even 0, or something like 3 minus I, or the square root of 2 minus 6i. And you also should know that if a complex number is a 0, then its conjugate is a 0. Which means if c is complex, and f of c is 0, then the conjugate of c, which is represented by c bar, is a 0. Oh man, that's really bad. I dropped my marker. You can really tell I'm kind of doing this with one hand if you haven't noticed. Then the conjugate of c, or c bar, is a 0, which means f of c bar is 0. And that's basically the whole gist of it. Finding roots and zeros of functions. You just have to know where to look for them. You can use a graphing calculator with a zero function to calculate and locate those zeros. And you're going to find in the next videos that there's going to be different tests that you can do to find out where a zero is, but you have to use some certain properties and also some certain tests. I'll come back to you with those.